Alright, today I'm going to show you how I go from idea to CAD, so computer-aided design, to template, to plasma cutting, to sandblasting, powder coating, and install of basically these strap brackets that I needed for my Dodge Ram. So it's a pretty simple, straightforward process, but I'll show you how I do it. Let me know if you have any questions. Alright, with any project like this, I'm just going to start it in the computer. I got the piece that I need to measure off of. So on Fusion 360, I just pop in here and go to the parameters, and I start the project by just creating the parameters. So I just name them, and then I put in all the measurements. So like, for example, the bolt hole diameter, which is the diameter of these holes. I just take that, pop it in there, and then I do that for the whole part that I'm going to do. Then I have all these parameters in here, so if I ever want to change the part, or like say I cut it out, it doesn't work out quite how I want to, I just pop in here, make one change or however many changes I need to do, and then it's done. So then I basically drew out a rough sketch of what I wanted the part to look like and filled in the dimensions. So let's see here if I can get, so you can see all of these parts are dimensioned, every little bit is. For example, if I want to change the parameter, say I want these to, be longer, all I got to do is go find the one deal that I have in here and pop it in and change them, and then as you can see now they're longer. So that's why I do it that way, because I like to change stuff after. I might cut one out and see how it works, and then maybe go through and change. Then I move on to extrusions. So I extrude the part. Let's see here. I extrude the part so it's now a body, and then I'll hide the sketch. So now it is actually a body, and it has some thickness. So I'm going to cut these out of 3/16, so I just extrude at that distance. And then for one of them on the back that I'm going to do, I created a little bit there to help even the force. I'm just going to be mounting it to the sheet metal of the bed. But anyway, so yeah, so now I'm going to move on to programming the part for cutting, and then we'll get it over to the table. Alright, so I wanted to test it out before cutting out a bunch of metal, so I hurried and went and plopped this into a drawing, and then just cut it out on the printer, and then cut it out with scissors on paper, just so I can get a rough idea how the fit is going to look. And then I went and tested it on the truck, make sure it's going to work there too. So everything works, it fits good, and it's going to be, should be pretty good for what I need it for. So just figured that's an easy way to cheaply test and make changes before having to cut metal and waste metal. So alright, I'm in the manufacturer workspace of Fusion now. So I just started by creating a setup. That's this little button right there, and then you just pick your model that you're going to do, and then the stock point. So that's basically where the X and Y plane starts. I always put mine on the bottom left-hand corner just because it makes it easy on the machine for me to line stuff. Some people will pick the center, depending on what I'm making, right? If I'm making one small part, I might put the center so that I can easily align it in a scrap piece or something like that. But in this case, where it's a little bit bigger, I'm going to make it just the left corner. I'm cutting out 4 here, and then I'll make another separate one for just 1, because I'm going to need 5 total. So alright, now I went ahead and created the cut profile. So you just push cut basically up here on the top menu, and then it pops up this little menu over here. So you pick your tool. So this is where you would, on your tool, you would set the kerf width and everything like that of your cutter. So you can create a new tool or use one that you have, but generally you can just create a tool every time. I use 0.05 or 0.055 inches for a kerf width. Has worked fine for me. And then in this case, I'm using 35 inches per minute for the feed rate, and then the lead in and lead out is the same. Then you go through and you select all your parts you want to cut, and then if you want in here, right here, you need to change this to in computer for the Langmuir Systems one. And then you roll around corners, and then if you wanted to leave stock, you can, or like tabs or anything like that, you can do that here. And then in this case where I designed it in Fusion, I'm not going to bother with smoothing. If I were to import like a part from someone else's software, it might have a lot of points, so I'll smooth it. That way the cutter doesn't kind of have a jag. And then I'm just going to use the stock settings for lead in and lead out that it pops up. Those generally work fine for me. And then keep nozzle down as well. That way it doesn't hit, it doesn't go over any spots where there might be tip ups. So basically what it'll do, instead of going straight across here, it'll take this path around to get to the next cut, just to prevent any clearance issues where I don't have the THC. Then you just push OK and it will generate it, and basically gives you a rough idea of what it is. I always simulate the cut real quick just to see, make sure everything's going to kind of work good, and there's no real interferences or anything like that. And as long as everything's all good on there, then I just move on to exporting it. You just click up here, right here, and then this is where you'll set your pierce delay. I use 1/2 second on 3/16 just because it gives it plenty of time to get through, and starts cutting when it's actually all the way fired through. And you export it, bring it to your machine, and we'll cut it out. Alright, I've got my metal loaded, I've got my machine plugged in, my air on and pressurized. I'm going to be cutting at 37 amps. I've also got the file loaded into the cutting computer that I have, and I have the part centered where I want it. I'm going to be cutting it out on this little corner over here with that little scrap bit. I'm just going to start by cutting out one so I can test fit it, make sure everything works and looks how I want to. It's going to be strong enough and stuff. Then we'll cut out the rest. But let's get going. Got the part off now, got it all cut off, and looks like we're going to be good to go. So this is the slag that's left. I guess it's considered dross when you're plasma cutting, but pretty lightweight part, should be pretty sturdy. That's thick enough sidewall. I think it'll be plenty for strapping down dirt bikes and stuff. Just test fit and everything. Yeah, those holes are going to line up good. So yeah, should work out good. I have a little bit of an angle on the part. That's actually quite a bit of an angle. I think my torch isn't perfectly level, but I didn't really test or look too tight on this one because I didn't really care too much. Just wanted to cut them out real quick. Where the angles go in the same direction, so you can see it's kind of slanting a little bit over there and a little bit down here. You can tell the torch isn't perfectly level, and that's how it is across the whole part. Whereas this way, it is pretty flat. So basically says that the torch is tilted a little bit. I'll probably fix it before I cut out the rest of them, but that's good enough for me, honestly, for this type of part. But yeah, so I'm just going to knock off the slag with a hammer, and probably we'll start to powder coat these next. Alright, I've got all the parts cut out. That round went a lot better. The edges, as you can see, are a lot more square. They're still not perfect, but they never will be on a plasma, but pretty good enough for me at least. Got all the drawings knocked off as well, so now I'm just going to hit them with a grinder and get these the sharp edges kind of removed, and then going to sandblast and powder coat. Alright, they're all deburred. I just use a flap disc, easiest way. I don't use my new ones though, I only use old ones because it kind of beats them up pretty quick. But yeah, so they're all deburred clean. Gonna probably go throw them in the Sandblaster real quick, put a quick etch on them, and then start with the powder coating. I've got about half of them sandblasted. So I decided I'm not going to sandblast half of them because I want to see how much of a difference it actually makes and like how durable the powder coat is. And also I have a cruddy air compressor, and sandblasting sucks unless if you have a high CFM air compressor. So did a couple of them. Gonna leave the others unsandblasted and just see how it looks and how it works, and then I can always strip them and redo it in the future if it doesn't hold up. But yeah, so I'm gonna set up the powder coating thing, and then we will jump into powder coating. All right, I've got my little powder coating setup all put together. So I just use a Harbor Freight powder coater. I don't do it very much, so it works fine for me. Have this little tent off Amazon with a box fan and just a air filter that kind of helps keep the mess down a little bit. It's still messy, but not quite as bad. And then I got my oven all preheated to 400 degrees. I have another video where I built that, so if you're curious, just check that out. But so basically now I got my ground strap hooked up. I'm gonna hook my air to my gun. I've got gloss black loaded up, and then just gonna turn it on and then use this to when I'm spraying, and it energizes the system. And I'll spray this all down and then put it in the oven for 15 minutes at 400 degrees is what this powder coat calls for. So I'll probably put it in for like 17 minutes because it's 400 degrees part temperature, not oven temperature. So that should give it about a minute or two to get that part up to temp. I think it'll be fine, at least good enough for this application. So I'm going to shoot those, and then you'll probably see when they're coming out the oven next. Alright, I've got them out. They're looking nice and glossy. They're hot as hell right now, so I'm going to let them cool for a bit, and then I'll show you one of them a little closer up when they're cooled. Alright, they're out of the sandblast, or out of the powder coating oven. Not perfect coverage, I missed a little bit. I can tell on the ones I didn't sandblast, it didn't cling to it as good. So, like this one for example, there's a little bit of, it's just not perfect. I might have put them in too long too, maybe it's just burnt. I don't know. But they're good enough for what they're going to be. I mean, they're just toe strap holders. So I'll just, basically now I'm just going to go get some bolts from the hardware store so I can bolt these all up, and we'll show you the finished product. All right, they're installed. They're super tough, gonna work good. I'm pretty happy with them. Just a couple M8 by 1.25 metric thread bolts. And then the fifth one is gonna go right up here. So I centered it out and just drilled my 2 holes. This is just sheet metal, so I'm not putting like, I'm not gonna be tapping this or putting like a thread cert into it at all. That's why I made this extra piece. So this is gonna go on the front right here, and then this is gonna go on the back. Matches the same holes basically, and then it'll just distribute that weight across the whole the whole bit of sheet metal rather than just the holes, and that'll help so it doesn't rip out. All right, got them all installed. Here's one down in the bottom corner already in, and the center one, and it's got the backing on it like I said. I use nylock locking washers too because I know the beds rattle a little bit, so it's gonna, I don't want them to come loose. Threads don't poke out, so there won't be any interference there, so everything's good. So yeah, that's it. Let me know what you think, if you'd change anything, or if you have anything that you'd recommend I do better. Like, subscribe, and see you later.